Let's try to know more on let's try to know more on how to solve exponential equation. And one of that is, aside from the laws of exponents, let's try to know also more on the property of exponential equation. So these properties can be used in solving exponential equation. So one is the one-to-one property of exponential function, which states that if x sub 1 is not equal to x sub 2, then b raised to the power of x sub 1 is not also equal to the b raised to the power of x sub 2. Conversely, if b raised to the power of x sub 1 is equal to b raised to the power of x sub 2. Okay, so aside from this property, one-to-one property of exponential function, we can have the property of equality, no, for exponential equation. So an exponential equation in one variable is an equation where the exponent is the variable. So in solving exponential equations, this property of equality for exponential equation can be used. So, and it is stated as, if a, b, and c are real numbers and a is not equal to 0, then a times b is equal to a times c if and only if b is equal to c. Now, to further understand on how to use this property of exponential equation, let's try this example. So this time we will be solving the given exponential equation. So let's try. We have 10 examples and let's take it one by one. First, we have this. 2 raised to the power of x is equal to 4. So one tip class in solving exponential equation for you to remember is to make the base in both sides the same. So make it sure that your base will be of the same number so that you can actually solve for the exponent of that. So we have here 2 and 4. Get the least common base for the two coefficient or bases. So for this one, remember that 4 and 2 is also a factor of this, no? So we have 2 raised to the power of x. We can take the 2 as our common base. And this will be raised to the power of 2, because 2 raised to the power of 2 is equal to 4. So we have here the same base now. So we can just get the x and the 2 here. So we have here x is equal to 2. Now, to check whether our answer is correct, or whether our answer is correct, so let's try this one. This first example only. So from the original equation, we have 2x is equal to 4, or 2 raised to the power of x is equal to 4, where your x is equal to 2. So 2 is being raised to 2 is equal to 4. And 2 raised to the power of 2 is 4, and that is equal to 4. So our answer is correct. Now let's try number 2. The number 2, we have 3 raised to the power of x is equal to 3 raised to the power of 5. So we've got the same base already, which is 3. So automatically we have x is equal to 5. So this will be our answer. And then for number 3, given is 2 raised to the power of x is equal to 1/2. Now, try to see our base. We have a whole number and here is a fraction. We can give the reciprocal of that based from our laws of exponents. So we have 2 raised to the power of x is equal to 1/2. In the laws of exponents, the reverse way is 2 raised to the negative 1. So we have the same base now, the whole number. So we have x is equal to negative 1. So that would be our answer. Now how about number 4? We can just have a space here. So number 4 is 4 raised to the power of 2y is equal to 4 raised to the power of 8. So we've got a base of 4, which is of the same. So we have here the exponent to y is equal to 8. We can divide both sides by 2 to get the value for y. So we have here y is equal to 8 divided by 2 is 4. So that's the answer for number 4. So I hope you're able to get the process, no, in solving for this 4 examples. So let's go further. Number 5. Okay, so for number 5, we have this example. So we have 4 raised to the power of x minus 1 is equal to 16. So we don't have the same base here. So the common is 4. So we can also change this 4 as its factor. So 4 raised to the power of x minus 1 is equal to 4 raised to the power of 2, which is 16 also. So we've got here the same base. So x minus 1 is equal to 2. So you have here x is equal to 2 plus 1. So your x is equal to 3. So there you go for number 5. And how about for number 6? Let's try number 6. And that number 6 is 125 raised to the power of x minus 1 is equal to 25 raised to the power of x plus 3. Okay, we don't have the same base. We'll get the common of it. So we have here 5, no? So 5 raised to the power of 3, which is being raised to the power of x minus 1. This one also 5 raised to the power of 2, which is also being raised to the power of x plus 3. So we can just get, we have the same base, and then distribute its coefficient, exponents. So you've got here 3 raised to the times x minus 1 is equal to 2 times x plus 3. Let's apply the distribution. Huh? So we have here 3x, 3 times x, then 3 times negative 1 is negative 3, is equal to 2x, then 2 times 3 is plus 6. So equating this one here, we have 3x transpose minus 2x is equal to 6 plus 3. And then 3x minus 2x is just simply x, and 6 plus 3 is 9. So your answer for number 6, x is equal to 9. Okay? So we have 4 more examples. I hope you're able to get the 5 and 6. And then let's try number 7. So class, for number 7, we have this example. 2 raised to the power of 3x is equal to 16 raised to the power of 1 minus x. So again, we don't have the same base, but we can just have the common base as the 2, no? So we've got here 2 raised to the power of 3x is equal to 2. So this time, 2 will be raised to what? So 2 will be raised to 4 to make it 16, because 2, 4, and 4 is 16. And this will also be raised to 1 minus x. So we have the same base now. So we've got here 3x is equal to 4 times the quantity of 1 minus x. So you have 3x, and distribute this one. We have 4, and then minus 4x. Okay? So equating this one, we have 3x transpose this So plus 4x is equal to remain the 4. So you've got here 3x plus 4x is 7x is equal to 4. To get the value of x, let's divide this both sides by 7. So we have here x is equal to 4 over 7. So that's the value for your x in that given expression. So x is equal to 4 over 7. Okay? And how about for number 8? Let me erase. So let's have number 8. The number 8 class, we have here 9 raised to the power of x is equal to 3 raised to the power of x plus 3. Again, let's make this same base. We can just get the least is 3. So we have here 9 is 3 raised to the power of 2 raised to the power of x is equal to 3 raised to the power of x plus 3. So again, we can just get the exponents of them. 2x is equal to x plus 3. So equating this, 2x minus x is equal to 3. So 2x minus x is just simply x is equal to 3. So that will be the answer for number 8. Okay? And then let's have number 9 this time. The number 9, we have 7 squared is equal to 7 raised to the power of z minus 1. So we have the common base already, so we'll just get the exponent. So we have 2 is equal to z minus 1. So equating this one, we can just transpose the coefficient number. So we have 2 plus 1 is equal to z. So you have 3 is equal to z. So this will be the value of your z as your exponent. So that would be for number 9. So try to see the 8 and the 9 example. And lastly, we have the number 10 example in solving exponential equation. So let's have the number 10. So for number 10, we have this example here. 1/2 is being raised to the power of 2x is equal to 2 raised to the power of 3x. So this one is a fraction and this is a whole number. Let's make this one of the same whole number. So we'll get the reciprocal of this in the laws of exponents. So we have 2 raised to the power of negative 1. Everything will be raised to 2x is equal to 2 raised to the power of 3 minus x. And then we have the same base as the whole number. So we have here negative 1 is being multiplied to 2x is equal to 3 minus x. And then multiply this one, we have negative 2x is equal to 3 minus x. Equating, transpose negative 2x, and this one will become plus x is equal to 3. So negative 2x plus x is just simply negative x is equal to 3. And let's divide both sides to make it positive, the value for your x, by negative 1 and also negative 1. So this will give you x, positive x, is equal to negative 3. And this is the answer for the last example, which is number 10. So your x is equal to negative 3. So with all the given examples here of the exponential equation, I hope you're able to apply, to learn also on how to solve for the exponential equation applying the laws of exponents and its properties. Okay, so this is for the solving an exponential equation. And then we will go further in solving exponential inequalities also. Let me erase this one first. Okay, if we have solving exponential equation, we also have our second subtopic, which is solving exponential inequalities. Now, to further know about exponential inequalities, let's take a review first. Now, which of the following are exponential inequalities? Knowing the last week topic, okay? So, I hope you're able to get that also, no? Identifying exponential inequalities. So, I have here 4 examples of the expression. Let's try to identify which are really exponential inequalities. So, the first expression, we have 2 raised to the power of x minus 2 is greater than 8. So, take a look at the exponent. So, the exponent, we have a variable of x raised to that base. And we also have the inequality symbol, which is greater than. So, what do you think? Is it an exponential inequalities? Yes, it is. Okay, so this one is an exponential inequality. Okay. Now, the second example, we also have here 3 raised to the power of x is equal to 3 raised to the power of 2x minus 1. So, the exponent is with a variable of x being raised to the base of 3. Yes, but the symbol in between the expression is equality. So, this one denotes not an exponential inequality. Okay, so we'll put this as X mark because this is not an exponential inequality because of the equality symbol. And then the third example, we have 2x plus 3 is greater than x minus 1. So try to see the variable of x. It does not serve as the exponent, but there is inequality symbol. So the whole expression is not an exponential inequality. So this one is x. The last example, we have 2 raised to the power of 4x plus 1 is less than or equal to 512. So we've got here the exponent with the variable of x being raised to the base of 2. And we also have the inequality symbol of the expression. So this one here is an exponential inequality. So we have 2 examples of exponential inequalities, which are 2 raised to the power of x minus 2 is greater than 8, and 2 raised to the power of 4x plus 1 is less than or equal to 512. So we only have 2. Now, let's try to know more about solving exponential inequalities. So, partly, we have to apply the property of the exponential inequalities so that we can solve correctly, no, the exponential inequalities. So, let's have here property of exponential inequalities. So, which states that if b is greater than 1, then the exponential function y is equal to b raised to the power of x is increasing for all x. This means that b raised to the power of x is less than b raised to the power of y if and only if your x is less than y. So that's one property of exponential inequalities. Okay. So we've got here the tips. So what is our tips now if for solving and knowing exponential inequalities? Okay. So there is a lacking portion here that if b also is less than 1, then the exponential function y is equal to b of x is decreasingly, no, for all x. So that means, this means that b of x is less than or is greater than b of y if and only if your x must be greater than y. So there's a lacking portion here, but you can see that in your modules. Okay, so again we have a tips. Be careful, class, when solving exponential inequalities such as b raised to the power of m is less than b raised to the power of n. The resulting direction of the inequality where your m is less than n or m is greater than n is based on whether the base b is greater than 1 or less than 1. Okay, so that is one. Those are the tips, no, in solving. So we always have to look for the base, that if the base here is greater than 1, so there you go, you will have to remain, no, the inequality symbol. But if the base is less than 1, then you have to reverse the symbol for the inequality. Okay? Sige. So let's try to know more further. In solving exponential inequalities. So aside from the properties, there are rules for solving inequalities. So we have this here. So again, we have the rules for solving inequalities. So we only have here 3 rules. I highlighted the important idea. So if the same real number is added to or subtracted from both sides of an inequality, the sense of the inequality is not being changed. Okay? Okay, it's not being changed. Why? Now, if both sides of an inequality are multiplied by, okay, let me repeat again. Sides of an inequality. So the sense of the inequality is not being changed. Okay, so I think this one there is something wrong. So aside from the properties of exponential inequalities, let's try to know more on the rules, no, in solving for this exponential inequality. So there are just 3 rules we need to apply. This is a long way in solving for the inequality. So first, actually I highlighted the very important ideas. So first, if the same real number is being added to or subtracted from both sides of an inequality, the sense of the inequality is not changed. So it will just simply remain. Second, if both sides of an inequality are multiplied by or divided by the same positive real number, again, the sense of the inequality is not changed. But if both sides of an inequality are multiplied by or divided by the same negative real number, the sense of the inequality is changed this time. So from the property of the exponential inequalities with the rules for solving inequalities, we can actually solve for the exponential inequalities. So this time, let's try having more examples. I have here 5 examples. Okay. To further know more about solving exponential inequalities, applying those properties and rules, solve for the given exponential inequalities. And let's try this one. First is number 1. So we've got here number 1, which is 3 raised to the power of x plus 1 is greater than 81. The same thing, class, when we solve the exponential equation, that we need to get the same base, no? Both sides of the expression. So if we have here 3 and negative 1, they're not of the same base. So let's take the least of the base of it, which is also a common factor of the other one. So we can just get the base of 3, both sides of the expression. So you have here 3 raised to the power of x plus 1 is greater than 3. To make it 81, we'll have to raise the 3 to the power of 4. Because 3 raised to the power of 4 is 81. Okay. So, again, the idea of the property is that if your base is greater than 1, so we have here 3 is our base. And let's say, try to determine if it is greater or less than 1. So, since 3 as our base is greater than 1, then the inequality symbol for our exponent will just retain or remain. Okay? So, solving for that, the value of x for our exponent, so we have x plus 1 is greater than 4. So, why do we retain the inequality symbol? Because our base 3 is greater than 1. So, let's try to solve for this one. X is greater than, transpose to the other side, we have 4 minus 1. So, your x is greater than 4 minus 1 is 3. So, for this one, if it is inequality class, we need to give the solution set as the answer. Okay? So, for number 1, we have x greater than 3. So, what would be our solution set for this? That means all values greater than 1, greater than 3, but, but 3 is not included as the answer. So, for our solution set, we can have this as open parenthesis, so you have 3, and then going to the positive value of your x. So, positive infinity, open also. Okay, so that would be the solution set. So, for this one here, 3 is not included as your solution. So, more than 3 to the infinity will be applicable as the solution for the given exponential inequality. Okay? So, that is the solution for number 1. I hope you'll get it. Okay? So, you have to end up with the solution set, not only up to here. Okay. So, let's try number 2 example. So, for number 2 example, we have 2 raised to the power of 4x plus 1 is less than or equal to 512. So, again, we don't have the same base because we have 2 and 512. So we'll change that of the same base. So we can get the base of 2 for 512, as it is also a common factor of the 512. So we have here 2 raised to the power of 4x plus 1 is less than or equal to. So your base of 2. So base of 2, if it is 512, that is being raised to the power of 9. And then let's try to determine using the property. So again, 2 is greater than 1. So if the idea, if 2 is greater than 1, that means the symbol for the inequality of the expression will not be changed or will not be reversed. So that means it will retain. Okay? So let's get the exponent solving for the value of x. So we have here 4x plus 1 is less than or equal to 9. So solving for x, we've got here 4x less than or equal to 9. Transpose the other one to the other side, minus 1. So you have 4x is less than or equal to 8. To get the value for our x, let's divide both sides by 4. So you've got here x is less than or equal to 8 divided by 4, we have 2. So for this one here, x is less than or equal to 2. So again, in the solution set, 2 is included as our answer. So for the solution set of this number 2, since 2 is included, and you've got here x must be less than 2. So we'll get the negative infinity. So the negative infinity, open for that, negative infinity, and then we'll have 2 as the closure. Since, why is it bracket? Because 2 is included as our solution. And so with the negative infinity. So any value for this will also be the solution set for the given expression. So you have to end up with the solution set as your answer if it is solving for exponential inequalities. Okay? So that is for number 2. So let's go further. For number 3, we'll have 3 more examples. So for number 3, we will have this one. 3 raised to the power of x is less than 9 raised to the power of x minus 2. So we don't have the same base again. So like we can take the 3 as our base. So we have 3 raised to the power of x is less than 3 will be raised to the power of 2 raised to the power of x minus 2. So again, we have the same base now. Again, let's determine if the base is greater than 1. So the base is 3. It is greater than 1. So we have to retain the inequality symbol in solving for x. So we've got here x is less than 2 times the quantity of x minus 2. So we got here x is equal less than 2x minus 4. So solving for x. So there are 2 ways we can solve this out. Since if you transpose the 2 x to the other side, it will give you negative. So I'll show you the 2 ways for that, which we can apply the rules for solving inequality. So first, we have this one. We can just have the positive, and let's just transpose the negative 4 to the other side. So we have here 4 less than 2 minus x. So we have 4 less than 2x minus x is just simply x. Okay? So we have here x is greater than 4. But on the other side, class, if we transpose the 2x to the left side, so we have here x minus 2x less than negative 4. So for this one here, it will give you negative x less than negative 4. So try to see, to give the positive value of your x, we will divide or multiply both sides by negative 1 to make it positive. So we have here negative 1 and negative 1. So this will give you x, positive x, and this one is also 4. Again, in the rules, if both sides are being divided by a negative real number, then you give the reverse way of the inequality symbol. So if this one here is less than, it will become greater than. So the thought of the two examples solution is still the same. That means x is greater than 4. So with the same idea here. So what would be our solution set for that? Okay, so the solution set. So we have here the solution set. So there is no equality. That means 4 is not included as the solution. So it's open-ended. So x must be greater than 4. So we'll get the positive infinity. So open parenthesis 4, since it is not included as the solution, and going further to the positive infinity. Okay, so that would be the solution set for the given example number 3. Okay. Now, let's have number 4. We're almost done. Okay, for number 4 example. So number 4, we have the quantity of 1 over 10 raised to the power of x plus 5 greater than or equal to 1 over 100 raised to the power of 3x. So the base is 1 over 10 and 1 over 100. We will have the same base. We can just have the common over 10. Okay, so we have here 1 over 10 raised to the power of x plus 5 is greater than or equal to, this one will be 1 all over 10 raised to the power of 2, because 10 raised to the power of 2 is 100. And this will be all over raised to the power of 3x. So again, we have the same base now. So 1 over 10. So let's try to determine if it is greater or less than 1. 1 over 10 is actually less than 1. So since it is less than 1 and it's not greater than 1, then we need to reverse the inequality symbol in solving for our x. So we have here x plus 5. Give the reverse way of this, less than or equal to. Okay, by the way, for this one here, we need to multiply also by its power, which is 2 times 3x. That gives you 6x. Okay, so we have here 6x. Okay, because there is also an exponent of the base of 10. So 2 raised to the power of 3x is also 6x. Okay, so we've got here x. So again, 2 ways in solving for this. We can just have this way. So taking the positive, 5 less than or equal to 6x minus x. So we've got 5 less than or equal to 5x, and let's divide both sides by 5. So you've got here 1 less than or equal to x. And if we have the other way around, x minus 6x transpose, we have here negative 5. So negative 5x less than or equal to negative 5. Divide both sides by negative 5 to make it positive. So you've got here x and positive 1. So, dividing both sides by negative, so you do the reverse way, x is greater or equal to 1. So, what would be our solution set for this? So, our solution set, that means 1 is included as our answer, and x must be greater than 1. So, going to positive infinity. So, close for 1, and that is positive infinity, open. And that would be the solution set for number 4 inequality. Okay? And then let's have the last example, number 5. So, last example, number 5. We have 3 over 5 raised to the power of x plus 1 is greater or equal to 25 over 9. So, this is different example also, no? From the last 4. So, remember we have 3 over 5 and then 25 over 9. So, we have to give the same base for this. And 25 is I think if we do the common factor, it's just the reversed way for the 3 over 5 also. So, we have to give the reverse way for this to make it 3 over 5 at its common. So, we have here 3 over 5 raised to the power of x plus 1 is greater or equal to. So, you give the reverse way for that. We have 9 all over 25 raised to the power of negative 1. That's the reversed way. So, let's give the common by common factor, which will also give us 3 over 5. So, we have 3 over 5 raised to the power of x plus 1 greater than or equal to. So, we've got for 9, we have 3 raised to the power of 2. 3 raised to the power of 2. And then 25 is 5 raised to the power of 2. And everything will be raised to the negative 1. Okay, so we have the same base already, 3 over 5. Let's determine that 3 over 5, is it greater or equal, greater or less than 1? So, 3 over 5 is actually less than 1. So, if it is less than 1, then we need to do the reversed way. Okay, so the reversed way of the inequality symbol of the expression. So, we can solve now this time. We have x plus 1, the reverse way of that, which is less than or equal to, multiply this here. So, the same thing, no? The same thing that we need to get for the reciprocal of that. Okay, so we have 2 over 2 times negative. So, again, if we have here, okay, we're done with this. So, negative 2 divided by negative 2. So, you have here x plus 1 is less than or equal to 1. So, we have x is less than or equal to 1 minus 1. So, you have x is less than or equal to 0. So, what would be our solution set for this? X, 0 can be a solution set for x. And x must be less than 0. So, we're going to the negative infinity. And 0 is included as our answer. So, x must be less than 0. So, that is negative infinity. And 0 is included as the answer. So, this will be our solution set. Since x is less than or equal to 0. So, 0 is included as your answer for all the negative infinity. Okay, so that would be the example for number 5, the solution. So I hope you're able to get the idea in solving with the different examples of exponential inequalities. Okay? So this time, class, I am done with my part, discussing with you, sharing ideas on how to solve for the two subtopics, which is the exponential inequalities and exponential equation. So I hope you're able to get the idea also. Okay, so for this time, you need to answer for our day 2 activity. So for our day 2 activity, now it's your turn. There are 3 activities which you need to answer. That is activity 14.1, laws of exponents, pages 2 to 3. Activity 14.2, property of equality for exponential equation, page 4. And lastly, we have activity 14.3, exponential equation and inequality, which is on page 6. So take note of your activity output for today. And again, a reminders. So reminders, class, please watch and learn all of the video lessons I prepared for you. And please don't forget to like this video lessons and subscribe this channel also, so that you will be updated in all the video lessons that I will be discussing to you. Thank you and good day, class. This is actually prepared by your senior high school math teacher, Ma'am Leia C. Gonsalve. Thank you.